Hey guys, welcome back to my channel, and in this particular video we'll be studying what microservices are. And in the previous videos we have already studied introduction to system design and what is the roadmap, like what all things you should know when you're preparing for system design. And in the second video we have talked about like what distributed systems are. So if you have not really watched those videos, I will say that start from video 1, video 2, and this is the video 3, so that you'll be like getting all the knowledge from sequence. Let's move ahead and see that what we are going to cover in this particular video. The first thing is we'll be seeing that why microservices came into picture. The second thing is we'll see that what is microservices architecture actually. The third thing is we'll see that what is the features of microservices, and then we'll iterate through advantages over it, because if anything is replacing something else, then there has to be some advantages for that, right? Otherwise why do we migrate or adapt new things? And then we'll be seeing that what are real world example, like the real world companies which are using microservices, right? So this is also important, like why which companies are using. There are several companies which I know and even I have interviewed for, and I will not be taking name, but yeah, they are still using monolith. And when I talked to their representative while interviews, they said that there is no need for us to go to microservices, and that pretty much justifiable also. Like, if you don't need it, why do you want to inculcate microservices and put extra cost to the company? So that's completely on your mm, requirements as well. So yeah, let's since this is the video for microservices, let's talk about microservices more. That okay, why microservice? And first thing is like, why do we need microservices architecture? Like, we already have, before microservices, what was the existing thing? There was something called monolith architecture. Okay, so as the name suggests, that a monolith architecture is like whole software which is composed in a single piece. So what microservices are, you might have idea, so we'll be talking about that also. So consider that there is a system, big system, and the whole software is composed as a single piece, and all the code is being written that there is no separation, and all the programs which are written are interconnected, and they are interdependent as well. So that was monolith architecture, and it is a tightly coupled architecture. Like, so what used to happen, like if you want to, let's suppose, fix something in one piece of the code, and you need to deploy the whole application, that is time taking also, right? So even I have worked on one of the project which was monolith architecture, which used to follow, that was a legacy product. So yeah, what are the major cons of monolithic architecture? So because of which we replaced monolith to microservices, and companies are adapting that particular thing. So it's very difficult to understand and modify the large and complex application. Everything in the same piece, and when you read the code, even when you segregate it is going to be very very difficult. And for maintenance, for fixing issues, for releasing, it's very difficult, and it's like a kind of mess. So that's the one reason. And because it was all like that, the development is slowed down over time. Things become complicated, people need to understand, some people leave, some people come, and they need to go through that code, and it's very messy. The development cycle and development process slows down in the monolithic architecture over the time. Over the time, the quality of code also degrades, because you need to fix something else will be broken, all those things, because everything is interdependent. You need to test everything, like if things are interdependent, you are making a small change, but whole application tester has to test, or even developer also has to say test, and it blocks continuous development also. Like, to display small change, as we talk, like you will have to deploy the whole application. That's the biggest disadvantage. you have one minor bug fix and you have to go and deploy the whole application. So that's one of the major disadvantage of that. It is pretty unscalable, because different services might require different resources and capacity to run. But since it's a one application, like everything written in the one piece, so scaling won't be done for all the services. Like if one service wants to use more resources, other service want to use less resources, you have to still provide the resources as whole into that. So it's kind of unscalable. You should be thinking about this. And when it's unscalable and blocks continuous development also, it's highly unreliable also. Like if any one thing failed, the whole application will be down. And this is like a very serious situation, and it makes it highly unstable also. So it's kind of not reliable. Like let's suppose tomorrow you are developing some application, and you have, let's suppose, some functionalities in which you can process photos also, you can process videos also, you can process mp4 audio also, something. And there is a glitch in, let's suppose, mp4 code or something. So ideally what should happen, like, okay, your mp4 code should not work until unless you should fix that, but user can use like other other since video functionalities or photos function. But in this particular thing is like, if something fails and everything is interdependent, it will fail the whole application, which makes it unreliable. Last but not least, it's quite inflexible, and you can't adapt new tech and framework easily. So for example, I'll say that, okay, you are developing something, and you are saying that, okay, I have a payment gateway system, which I want to now write into some other language. Let's suppose it's written in some old language, you want to change it to Golang. For any reason, it might not be correct that it's the best suited, but I'm just giving you example. And it's very difficult because here you cannot adapt a new tech and new framework easily, because you have to migrate the whole code, and that's the biggest problem. And that's what the advantage microservices provide is, like, you can, different services, you can use different tech stack. For example, the last company I was working in, one of the service was using Python, one of the service which was talking to legacy gateway or legacy system, was written in earlier C sharp, and rest of the services written in Java. So this is the flexibility which we get in microservices, which was not there in monolithic. So that's why I think this microservices comes in picture. Now let's move ahead and see that what is microservice architecture exactly. So as the definition says that, here you can see, microservices architecture is an architectural style, obviously, since the name is there, that microservice architecture, it's an architectural style that structures your application as a collection of small autonomous services modeled around a business domain. So these services are capable of doing one thing in itself, and they are autonomous, and it is like they're kind of interrelated uh, with each other using connections, network connections, or some APIs, anything. But their goal is same. All the services will combine up and serve one goal, but they are different. For example, let's suppose you are developing some e-commerce application. So you can have, like, for your cart, one service, for your payment, one service, for your when you log in user and all those things, for another service. And similarly there will be many things, like for recommending users that what to buy, what not to buy, you can have recommendation service. And many things. For example, if you are using, let's suppose, if YouTube kind of a video streaming, so you can have something which will handle encoding and decoding, some service that can be a microservice, like, right. And some service can be handling uploading or downloading of videos, anything sort of that. Or some service will be responsible for all the data analytics which we see, like how many views and uh, how many things, how many people are coming to watch videos and all those things. So different services, but they'll be serving one goal. But yeah, as you can understand, and your payment can use Java, your cart can use Golang, and your analytics service can use something else. And even the databases can be different, like for storing user information you might use SQL, for other things you might use NoSQL. So all those things are pretty easy. So you can see that in the diagram here, like there is microservice 1, microservice 2 until n, and they are serving one business domain. So this is a kind of microservice architecture. I hope you have a little bit clarity over this. So as already written and explained, that each service is self-contained and implements a single business capability, which I've already explained. And now talking about like communication within microservices is like stateless communication. And if you don't know, then you should be reading about the stateless communication in deep on Google maybe, or I'll be covering it in some videos. I don't know. Not having any plan for now. I hope that you will be aware of this. And coming here to architecture, let's suppose, let's see. So here you have one client. Okay, that client can be your mobile or your another desktop, or even some other service also. Yeah, let's suppose. So how many of you have, this is an example I'm giving, like let's suppose you use WhatsApp, right? And how does WhatsApp generate money? Through WhatsApp business. So that's how WhatsApp business is one of the application. But for them, the clients are who are the clients, like Make My Trip is one of the client. Like whenever you book a ticket, they call WhatsApp business API, and they send tickets and all to their customers onto that. So they might be client, might be you also. For YouTube, you are the client either on desktop or on mobile, anything. So yeah, so this is a kind of client. And then I'll be covering a client server architecture somewhere in these videos. So if you are not aware of client server architecture, just try to understand this, and I'll be covering that in one of the video. So what happens, like client calls. So that's one thing I said, that different microservices are self-contained, and they talk, like they do communication between each other, and it's pretty stateless communication. But what happens, that the client will not directly talk to all the services, because in the distributed system video I've already explained that uh, the complexity of those things are hidden from user will talk to API gateway, and API gateway then call the service through APIs, or if they want to discover any microservice, there is service history, discovery, all those things. So that will be like in another detailed discussion, like what is service discovery, how does it do that. But here our goal is not that. We are studying microservices generic, that you should understand. And then you can see that there are microservice, service 1, service 2. Service 1 2 can also talk to each other, and API gateway will call different service to purpose. There might be a remote service, like, so let's assume whatever I said, right, client. And now you see that, let's suppose this is WhatsApp service. Okay, and this is, let's suppose, this Make My Trip service, or whatever. So they can call remote service, like their application is calling remote service, right? So for this remote service, they are the client. That's what I was explaining earlier, right? If you have any confusion, like, you can comment it down, and I will be answering that also. And then there can be different things like CDN cache, static, for static content, for management, service discovery is here, like how will you discover different microservices. So this is a kind of architecture which is being followed. Okay, I hope you understood this. And as I said that, right, like each service is responsible for persisting its own data. So either you talk to a database or something, and you store, or you store it on your own. And you should not be responsible for these two, on other services. So every service should be self-contained, and it should be self-sufficient as well. Like self-sufficient in the sense that one functionality which is doing, not whole. And as I said, that in distributed system also, that implementation is hidden from other services, like not only user. So one service like payment gateway, whatever they are doing, it is hidden from the cart, or whoever is calling even the payment. Let's suppose the cart is getting checked out, and a payment is being called. uh, Cart doesn't know that what it does. It will simply say that, okay, this is this, and this is the amount total, and you should go and take this one money and just deliver the product, whatever. But here, like even the other services, let's suppose in e-commerce only, there is a Prime membership. Okay, so Prime membership service can be different. Like, who are the Prime members? So when payment gateway will be called, the payment gateway will even talk to that service Prime, whether these are they eligible for free delivery. If yes, Prime membership service will return back the response that, okay, the delivery is free for this particular guy, so don't add. I mean, don't add as in subtract this much amount from that. So something like that. So they don't aware about other services. They know their own implementation, and it should be hidden also. And yeah, tech stack can be different, as I already said to you, that some service can use Java, some can use Golang, some can use Python, and I have worked onto it where Java, Python, C sharp used to have use. So I know that, and it's pretty easy also, like to as per your need, as per your requirement, you choose your stack and start working. Let's see that what are the features of microservice architecture. So first feature is small focused, like in the whole e-commerce world or in the video streaming world, small focuses will be given to microservices. Like payment service one, and cart is one, user and all those things, login, everything is done one. And like, not login will not be in one service, like can be handled in the API gateway as well. Just to give you example, I was saying. And in YouTube, I already said that encoding, decoding, and all those things can be different, right? And then they are loosely coupled, obviously. Like if your payment service is failed, you need to fix the issue and deploy only payment services. The rest everything is working there, because they are being calling that particular thing, so you don't need to deploy whole application. It's very simple. They are language neutral, already told. This is kind of repeated. Language neutral, and there's a bounded context. So no need of understanding the implementation of other microservices by one microservice, which is okay. And there can be different teams working on it. Like, so Amazon Prime, if you see, and in Amazon Prime, right, whatever this Amazon Prime service, benefit service will be there, right? There will be different team for handling this. And let's also, for payment, there is a different team. So don't think so that same engineer is working onto that. And they, if they are like, it happens like, if you are very eager, they might know what is happening inside that, but the services, they might don't know also what is happening, how it is being implemented. It's like they are client for other service. So there is no need of understanding the implementation of microservice by other microservice. Let's move on to the advantages of microservices. It's very simple: independent deployment and development. So if something failed in the card service or something failed in the encoding service, they will only be deployed after fixing. Mixed tech stack: you want fast development, you can use Python. Even you can later on remove that. You want something else, some other functionalities, you want something, you want to use it in Java, you can use Java later, write something in something else also. You can changing also is very easy into that. So mixed tech stack. And then fault isolation: one service goes down, whole app will not go down. So this is one of the advantage. And then there can be a granular scaling. So let's suppose my one service is very heavy and the other service is very light. So for one service we can increase resources, okay, and the other service which is light we can allot uh, less resources, less computation power. And if you are using cloud, I mean like AWS or Azure and anything like a startup does, so it's very important, like whichever thing is using more resources, it should be allocated that, and we should not be consuming unnecessary bandwidth, because there is a cost associated with every transaction, everything. So yeah, that's like granular scaling. I hope you understood. I'm saying it again, like you can comment down, I'll try to answer your question if you have. What are the companies using microservices? Even Amazon is using, Twitter is using, Netflix is using, Uber is using, even Walmart is using. Every one of the companies like which are developing new code, and they're trying to move to microservices because of these benefits into it. So that's it for the video, and if you want to follow me anywhere for educational content, this is my ID Thayo Ashish, and I'll be completing this system design series over the time. I'll try to be more consistent. All my learnings I'll be putting it into this series. I hope uh, this will be beneficial for you guys, and the whole series in sequence, 1 2 3 part number, you'll be getting it. So yeah, stay tuned and we'll see you in the next tutorial. Bye.